Okay, for number 11, it's a root. I see a quadratic on the inside. I would probably try to complete the square on it. And let me just go through that, sort of briefly with you. So if I were complete a square over here, and let me just go back and get my pen back, I would write down, and this way I do it. You may say, I want to do it differently. You can. It's going to be the same outcome in the M. I'd factor out -1. You get x squared plus 6x minus 7. Right, what I do is I take half of the 6, which is 3, square it to get 9. Now, I want to point out, really what I'm doing is subtract the 9, so I've got to add 9. So let's put this down. So it's going to be -1. And then what do you get over here? Let's be careful about this. You're going to get, this is a perfect square here, and that's going to be x plus 3 squared. I got that done. -1 times -7 is +7, and +9 is 16. I'm going to rewrite this a little bit differently. This is 16 minus x plus 3 squared. Again, for a lot of students, that looks like magic. What I suggest, if you think it's magic, just multiply it out, see if it's true. So it's 16. What's x plus 3 squared? It's x squared plus 6x plus 9. What do you get there? Well, 16 minus 9 is 7. Then you get -6x minus x squared. Is that what you expected to see? That's what you expected to see. All right, let me show you where that's written. Again, we're expecting to see this written somewhere, and I do see that over here. So let me get my eraser out and say, I understand that part. I understand how they got there. Now, someone says, why would you do that? It's a typical strategy. And the strategy is you're starting to recognize that this has something to do with trigonometric substitution. All right. So looking at it, and again, you may have to go back and review that. A lot of times I can't remember things, so I want to go back and review them. But I would say, x plus 3 is equal to 4 sine theta. I would differentiate. I get dx. That equals 4 cosine theta d theta. All right. Let me point out where we are again. My eraser out, and I'm going to be making a substitution on this guy over here. All right, let me put that down for you. Put a little star over here. Put a little fraction bar down. And what do you get in the bottom? Well, the bottom's fairly simple. It's going to be 16 minus, well, you have to square this thing because it's x plus 3. What would you get? 16 sine squared. All right, now what else I have? I have the dx there. What's the dx? It's 4 cosine theta d theta. All right, now for some students it actually looks worse, but it's actually getting better for me. And what am I looking at over here? Well, the top is just 4 cosine theta. This is d theta. On the bottom, I factor out a 16. The square root of 16 is 4. And then you left off with 1 minus sine squared theta. What does that give you? Well, the 4's cancel, so you're left off with cosine theta. And 1 minus sine squared theta is going to be the square root of cosine squared theta. So the square root of cosine squared theta, absolute value, but we get an invertible region over here that we're not too concerned about that. So I'm going to just simply say it's cosine of theta, d theta. What does that give me? That gives me 1 d theta. What's its antiderivative? It's just theta plus some constant of integration. But remember, we got to go back to this, theta. And the way I do that, I look at this equation over here, and I have to solve that for theta. So it's x plus 3 over 4 equals sine theta. So what's theta? It's the arc sine. I'll write that down for you. This is plus c. We'll look at a key in a moment. X plus 3 over 4. All right, look at the key. I'm seeing that right over here. Thank you.